You are probably watching this video because you are in the DevOps Academy course. If you haven't heard about them, it's definitely worth checking. It's all free, public, and open source. So if you want to know a little bit more, I'm going to put a link in the description. So this video is a walkthrough with some general explanation about the exercise, and hopefully I will have time to post more videos. So if it helps, please let me know here or via Slack. My suggestion is that you do first the exercise by yourself so you can better understand some of the details or like the things that I'm going to be saying here. While this video is not from the DevOps Academy itself, all the answers from other students are available and public, so I don't think there is any harm done anyway. You may notice that I make a lot of mistakes while I'm recording, and I will not edit them out. That's because learning to read error messages or problems and making mistakes is all part of that learning process. Okay, so as you can see, the objective here is to create two EC2 instances, which are the virtual machines or virtual servers that run inside AWS infrastructure. The first one is going to be public. It's going to have a public IP, which means it's accessible via the internet. And the second one will be private, which means that it cannot be accessed directly over the internet. But you can still access the private machine by first connecting into the public one. And then from the public, you can connect to the private. That's called host jumping. So there is a lot more on how the private and public networks are configured, but we are going to take a very simple approach here. And I'm sure that later on in the course, we are going to address a little bit more about the VPCs. One last thing that we want to notice before we jump into that is that the exercise is going to ask us to do that via the terminal, via the CLI. If you haven't set up your AWS CLI yet, I would suggest you to have a look in the course material before you do that. But for the sake of this video, I'm going to do that via the console first, via the AWS website. That will demonstrate what we want to achieve and how to connect via SSH and this kind of stuff. And then later on, we're going to redo that via CLI. Anything else? Let's create our branch and prepare the answers file before I end up committing stuff to the master branch by accident. We're only going to type the answers after we are doing the CLI exercise. Right now, we're going to go do the console one. Now let's head to my AWS account, and we are going to create our first EC2, which will be the public one. So let's go. We're going to launch a new instance. I'm going to select Amazon Linux, which is eligible for the free tier. If you are, select that one. I'll select the size of the machine that you want to use, how many CPUs, how much memory. The higher end, more expensive it will be. You can get just the cheap ones for this exercise. Now the details. Let's not get into all this details here. There's a little bit of information here that we don't need right now. Most important, the exercise asks us to use the default VPC, which is here. I'm not going to select any subnet right now. And one of the important things is here, auto assign a public IP. You can see it's enabled by default, or you can just select enabled anyway, because that's the public machine that we are creating right now. Storage, I'm not going to change the size of the disk, doesn't matter right now. Tags, you can add a name if you want to, that's not required. I'll call this one console public test and security group. So security group is important in this case because we want to allow SSH access into that machine. I'll just create a security group here that I'm going to reuse later. I'm going to call it allow all SSH and just describe allows SSH connections from everywhere. You can see here that that's protocol TCP port 22, and this mask here means all IPs. You can see here from anywhere. That's added this notation. Now let's review. It's all good. It's giving a warning because this machine is open to everybody, but it's okay. And let's launch it. Now that's an important part of the configuration. Here you're going to select a key pair, and a key pair is a credential. It's something like a password that allows you to connect to this machine as a root, as the administrator of that machine. If you don't have the key pair, if you lose it, you basically don't have access to that machine. There are workarounds, but for now, let's just consider you lose the access to that machine. So let's create a new one. And I'm going to reuse that for other machines later. Let's call it DevOps Academy test. And you need to download that key pair. AWS even prevents you from launching it if you don't download it. Because again, without that key pair, you don't have access to that machine later. Now it's downloaded. Let's launch. Seems like everything is okay. Let's view them, and there you go. It's initializing. Okay, we can see now that instance is already running. It didn't pass the status check yet. You can wait a little bit more and it's going to get green here. But we can even start moving on with what we want to do. So we want to get inside that VM, that virtual machine, so we can access its files and see what's happening over there. So let's just open a terminal here. And let's jump into it. The syntax to connect via SSH, it's quite simple. You type SSH and the address of the machine. The address is the public IP that it's here, and you can copy. You can also use the DNS, that's the same thing, but you can just use the IP if you want. And as you can see, first it's asking you to confirm that this is the identity of that server. What happens is that when you install a new server, when you install the operating system, it's going to generate a key, a unique key for that server that can identify who you're talking to. And that if you install another server, it's hard, unless you have that key to copy, you're not going to be able to pretend you are the other server. And because it's the first time we're connecting to that server, SSH is warning us that it doesn't know if that server is the correct one, if it has the correct key. We're going to say yes here, and then it should just work. Right now it's not working for another reason, but if you can see, I run the command one more time, it doesn't ask me again. Why? Because it knows that this server is the server that we wanted to connect, because before we said yes, and remembers that. If by any chance someone is trying to impersonate that server using the same IP, or there's a problem, this operating system is reinstalled or something like that, we are going to get a warning here. We are not going to be allowed to connect to that server. SSH is going to detect that there's something wrong going there. But the first time you do it, it's okay to answer yes, especially for the sake of our example here. We don't actually have to verify the authenticity of that host. But then we have another problem. It's saying here that the permission for Daniel at this IP is denied. That's because I don't have a user there called Daniel. The name of the username that these machines are created are EC2-user. So when you use the Amazon Linux, that's the username that it creates for the administrator. This syntax is user at and then the IP address. And there you go. You can see that I still have permission denied, but now the user is correct at least. The reason is I need to provide that key that I tried to use before, that I downloaded before. How can I provide that key? There's a parameter, it's -i, to provide the identity file, and my file is in downloads, and that's the file that I downloaded at that time. So SSH -i, the file name, and then the username and the host. Now, you can see that we have another problem here. The problem is that our private key file is not protected. What's happening is simple. You can see here that everybody in my computer has access to read this file, which is a potential security breach. Anyone can access that server as root, as admin. Also, everybody in the staff group has read, which is also not very good. So we want to limit that. How do we do that? Let's change the permissions and make 6, which means read and write, for the owner, which is me, and 00 for the group and for everybody else. That effectively removes permission from everybody else except me. Now that the private key is protected, I guess this is going to work. There we are inside our newly created EC2 instance. You can list the files there, you can see where you are. You can even create a file called public EC2. So later we can easily see where we are. Okay, so that's how we create and how we access the EC2 instance after in AWS. Now, there's another way you can connect. So I'll just log out from this one. I can type exit, or log out, or I can just type Ctrl-D to get out of that. If we don't want to use this identity file all the time, we can just add that to an SSH agent. SSH agent is a service running in your computer that's going to provide the keys when needed to connect to a server. How to do that? SSH add, we provide the name of the file, and it's going to say that the identity was added, which means that now we don't need to provide that file anymore. Our SSH agent is going to provide the correct file. Actually, it tries every file there to connect and authenticate to the server. Now, there is also another way. There are many ways to do things, of course, but there is another way where we can configure how to use identity files. That way is using SSH config. So let me show you here. Inside your home directory, you probably have a folder called .ssh, and inside that folder you may or may not have a file called config. If it doesn't have, you can just create that. And that's the configuration for your SSH client. Here we can add some directives, some parameters. So let's say that every time I connect to the following host, and let's get here our public IP. When you do that, let's say that I want to use the identity file that's in my downloads. And that's the identity file. So if I typed it correctly, that would also use that identity for that particular host. That's just another way that we could use to specify which host has which identity when you have multiple identities. I'm not going to save this because I'm already using my SSH agent, and that concludes our public machine. Our console and create our private machine. I'm going to launch a new EC2 to select the same thing. The only difference this time, is that I don't want a public IP. And I'm going to use the same allow SSH security group that I done before. Seems like everything's okay. And I'm going to use that key pair that I created before. Okay, it's creating, and let's see it getting green very soon. Okay, the machine is running now. I'll just give it a name that I forgot to give during the creation, and it's ready to go. So how can we connect that machine? There is no public IP, so there's no way I can actually just connect straight away. Yeah, but there's a private IP here. Yeah, but it's not going to work. As you can see, it doesn't know how to connect to that. That's because that's a private IP. We are probably going to see a little bit later in the course that some IPs, they are reserved and they can only be used on private networks. So they're not going to be routed. They're not going to be working over the internet. And that's one of these IPs. So how can you access that, that specific machine? Well, you have to go to the public one. So let's get the IP of the public one. This time I'm going to do a little bit different. I'm going to use the public DNS, which is basically the same thing. Remember, you have to use the EC2 user to do that. It's going to confirm now the identity because I'm not using the IP, I'm using the host name, so it doesn't know if that host name is the correct machine. Let's confirm, and there we are in the public machine. So how do we get the private one? Well, in theory, I just have to connect there, but it's not going to work because we don't have the key here, the credentials, the private key that we need to use. Remember that we had to use -i before, and then I added an agent. That's why I don't need to do that anymore. But that key is not on the public server. So when the public server tries to connect the private one, it doesn't have a key. There are a few ways to go around that. The easiest one, I think, would be simply getting our key there. When I do cat, it's going to show all the contents. Don't worry, when I put this video online, this key is not going to be active anymore, so I can expose it, but that would be a security breach if this key was exposed like that. But anyway, I'm going to get this key. I'm going to copy. I'm going to jump into my public machine. I'm going to paste that here, and I'm going to SSH using that key to the private one. Remember, I didn't change the permissions of that key, so as you can see, I cannot access it yet. So let's do it. Let's protect that key and try again, and there we are. And you can see that we are inside the private machine. Just so you know, we could as well, instead of copy and paste, which is kind of ugly, we could just have used a command called scp, which is SSH copy, and that to do that we have to specify where we want to copy it. So it's the user at host, and then which folder. I'll just put in my home directory, and that's another way to copy files across SSH. But Still, that's not really good because this key is there exposed. Well, not really exposed, but it's in the server, and anybody hacks that server, they would get that key, or any administrator could get my key and start using my credentials to access stuff, and I don't want that. So let's remove them from here. Let's go back to our machine and let's try a different way. So as you remember, I added that key using SSH-add. So it's my user agent that has the key. What I can do is when I go into my public machine, I can forward that agent, which means that now when I try to connect to the private one, I don't need the key anymore. When I try to connect the private one, the public machine is going to ask my computer, my host computer here, for the authentication, for the keys, and then it's going to send to authenticate into the private. So now we have no files or nothing saved in this public server that could compromise the security. It's all done via tunnel, via SSH. Okay, that's another way, but there's of course even another way that we could do that. Instead of SSH into the public and then SSH into the private, we can do that in one command. How do we do it? So let's show you. I'm going to get here the DNS of the private machine, which should not even resolve from my local. You can see it's not working, and it's not because of the user. It's that DNS is not even finding what's the IP address where it needs to connect to. But instead of doing that, I can tell you, hey, SSH, I want to access that machine, but I want you to jump through this machine, and I'll put the public one there. And I'm putting the public one there. So what happens now is that when I press enter, SSH is going to jump into this host and then jump into the private host. So the first thing it's asking here is, well, it doesn't know, like my local machine has never accessed that private machine directly, so it doesn't know the identity of that machine and asking us to confirm it. Remember, the public machine knows about the private, but not my computer. And there we go. If everything worked out, we are inside our private machine with just one command. And this is slightly better than doing the two hoops, SSH into one and another one, because this is actually being handled directly by the SSH client. There are many more options we could do here. We could do port forwarding, we could do proxies. There are many things we could do. And using this syntax, it's all done all the way to the endpoint. It's a tunnel that generates. It's like my machine is connected straight away to the private one. Of course, it's still using the jump host as middle there. Well, just one example, I could just from here list the files in that private machine in one single command. Okay, so now I'm going to give you a bonus trick of how to configure SSH using the SSH config file. So, wouldn't it be nice if I could just come here to any private address that I have? Imagine that I could have many things there, and I could just do this. That would be really cool, right? So we can. All we have to do is configure SSH to do so. So we are going to create this file. It's in your home directory, a folder.ssh/config. If you don't have this file, you can create it. And then you're going to start setting up some rules. The first thing, we have to set up our proxy, our jump host. So let's call it jump host. Okay. Now that you're going to have this host, we have to define who is the host name for that. Let's find the public one because that's our Jump host, and let's get the DNS, or could be the IP, doesn't matter, and set. So when you try to do, I'll just open a new screen here. So when you try to do SSH Jump host, it's trying to connect to that host there, but it's still getting the wrong username. So let's just add the correct user. The user is EC2 user. And there we go. Now we are connecting to the Jump host. So all we have to do is put that name that we put there. We don't have to because we already added to our SSH agent, but we could even add identity file here, and we would put that to be the private key used to access that. I don't remember the others. We don't need to do this one in this case because we have that in our SSH agent. But if you wanted to specify exactly where the key is, you don't want to add it for every connection, you could specify the key here. Okay. But that's just part of the solution because it still didn't fix our problem before. What do we want to do? What we want to do is we want to connect to that host here, right? So when you connect to that host here, we want to do a proxy jump, which is a proxy jump via the jump host that we created before. So now when we try to connect to that one, it's trying to use the jump host. Again, same problem, missing username. And there we go. Is it working now? Yes, it is. That's really good. But you don't want to do that for every internal host that you have in your AWS. Let's imagine that you have a lot of servers, a lot of private servers, and you don't want to need to configure one for each of those. So you could do something interesting. We could do a match. Okay, we could match anything in Sydney, or why not? Let's match anything that's .compute.internal. And that's going to connect via proxy jump. And there you go. So now, even if I create the new EC2 inside this network, and I don't have a public interface, I can just use the internal address now, and it's just going to work for me. Good, but we forgot that the request of the exercise is to create them via CLI, not going by the console and clicking buttons. So how do we do that via CLI? So there's a page here where you can find the guide, but you don't even have to remember it. I'm pretty sure that if you look for EC2 AWS CLI create instance, you're going to find, and there you go, like have documentation and everything. So you can get that one, for example, and find the command line. That's the syntax, create instance, and everything that you probably need to know. But if you get the other one, you have here one example. So you're going to find some material there. So let's go. AWS EC2 run instance. If I press enter here, it's probably going to complain about the image. And it needs to know what's the image ID. And what is the image ID that you need to give there? Remember, when you click launch instance, the first thing that it asks is what image that you want to use. So if you do a help, you're going to find all the parameters as well that you need there to do. So here we go, image ID, instance, image ID. Let's get this one. And if I press enter here, I'm very confident I'm going to create a machine. I'm not really sure what size of machine it's going to create. I hope it's not a huge one, because that's going to be very expensive. Let's play it safe and let's specify which machine you want to do. So let's check the help again. And we're going to see here. It would be helpful if that was a little bit sorted, but that's not what we need. That's here. Okay. So type that I want a T2 dot. I will use nano this time. I'm not on free tier anymore, so it doesn't affect me. Actually, it's even cheaper this one. Yes. So if I press enter here, I'm very confident it will. Oh, it will either ask me for something that's missing, or it will just create with some defaults, and that's what happened there. It's creating that with some defaults. So yes, it created that machine with some defaults. I don't really know what they are. You have to be a little bit careful when you're running these commands, because sometimes you might create some expensive stuff, and that's why I went straight away on selecting the type at least before going ahead. But what happens now is that I don't have a key. I mean, what's the key for that machine? I don't know. So let's go have a look. And there is no key on that machine, which means that I cannot access that via SSH. So let's provide a key for that machine. If you go in the help, you're going to find out that the name of the key pair is key name. Now the problem is, well, we have some keys here, but let's consider that we didn't create anything via the console, so we have to create a key. So let's get the key name. I'm cheating a little bit because I just got the solution to make it easier, and the command is AWS EC2 create key pair. Let's give it a name. If you do a help here, you're going to see all the syntax, or you can just Google for it and find the answers. But I know that I need to provide a name. And that's my key pair. And I forgot to activate my AWS profile on this one. Generally, you don't have to worry about it, but if you know how to do profiles, I think it's a good idea to not use your default profile as something with lots of access. If you run a script, or if you run something that tries to use your current credentials to access or create something, if you don't have it defined, I think it's an extra security measure that you have, that not any script that's running your computer can just use your credentials. So my default profile is actually blank. Sometimes I used to have it just a very weak read-only profile, but even that I decided that it's not worth it. When I want to use, I have different profiles for different stuff. This one is for my testing, which is almost has almost full credentials, full permissions, but I don't suggest you to actually have that active in your terminal all the time. But going back here, let's create the key pair again, and there you go. We have our key there exposed, because that's the output of the key. What we can do, we can say that we only want that particular field to be output. So you can see before we had an JSON output, and now we have just the string of the output that we need. But we still need to save that somewhere. So if you know how to redirect things, it's very easy. So now that we have what we need, let's create it properly. I'm going to add this in my SSH directory, and I'm going to call it. I made a mistake there. I had to go back in this video so you don't follow the same mistake as me. I forgot when I was adding the key to put the minus, to set the output as text. So if you remember, when I generated the key, I forgot to set the output as text. So that was the command that I just did. But if I remove this, you're going to see that it returns a string, and that string has these quotes here and has this /n, which means that string is encoded as JSON. It's not supposed to be used as is. To use it as is, I have to set the output to text. Like that, like that. Now that's correct. Our key should be here now. Now, because we're doing the exercise, let's copy this command, because that was part of what we need to provide. Create key pair. And let's add that command here. Because you're doing a shell, I like to provide a hint of what kind of content is in the markdown here. You could do this. IntelliJ actually provided this, but many times I just put like that. I'll keep like this. So we created a key. Now we also need, we can run the create instance and provide that key to connect. But I know that the next problem we're going to have is that I'm not going to be able to connect via SSH, or worse than that, my machine is going to be completely open with a default security group or something like that. So we need to create our security group, and after that we also need to allow the rule to access SSH. So again, you can Google for that. You can check the AWS documentation, and you're going to find out that the command is create security group. What do we need to provide is a description and a group name. So the description is going to be allow SSH from anywhere, and let's say group name going to be test allow SSH. And I misplaced a quote there. When you see this D quote or quote here, that's because you probably forgot to close a string. Honestly, I didn't even need to quote that parameter there because it's just a single word, but let's continue. So now that we create our security group, let's find it here. It should be here somewhere. Test allow SSH is here, our security group, but there is a minor problem, which is it has no rules. Oh, let's save this command. And let's move on to this. So we have to edit this inbound rules. I have to add a rule, and you have to use SSH on port 22 from anywhere. I don't really care. This is IPv6 right now. Let's not bother about it. That's the rule I want, but that's cheating. Let's not do here. We have to do that via the CLI. So remember, going to the official documentation is always better, and you are going to find it here. The command is authorize security group ingress, and that's inside EC2. Okay, we probably have an example here. AWS, there you go. Oh, actually, perfect. Here you go. Allow SSH, that's what we need. The only difference is we don't want this one. We want that mask, which means anywhere. And also, this ID here is wrong. Our ID for the group we created is this one. And I didn't get any output from there. Let's see if that's a silent success. Yes, it is. It's here, as you can see. So let's add this thing here to our documents. Cool. Now we need to do what next? We have the security group, we have the key pair. We have to say if it's a public machine or not, because we're going to do that twice, one for each machine. So when you run this thing, let's just find the key name. What was the key name again that I forgot? That was the key name. And how is security group? You could just go in the help there and figure out that it is security group IDs, and that's the security group that we want. Oh yes, we have this information. Let's see what else we need. I'm a little bit lazy to Google. I'll just use the help. And let's have a quick look here. Run instance. I'm not going to provide, I'll leave the block, which is the disk by default. I provide the image ID, provide the instance type. Don't care about that. Providing a key name. Don't care about all that. Security groups I am providing. Subnet ID I'm not going to provide. We're going to use the default VPC as part of the exercise. User data, that's what the machine is going to run when it starts. Don't have to worry about that. We are going to need some tags, which means we are going to need to use this tag specification. The syntax for this one is a little bit annoying. Let's go back to that later. We are also going to need the public IP. There you go. So the first one you're going to run is going to have this one, and the private one will have no associated public IP address. And I think that's all we need. Now, going back to the tags, when you run the tags, we can tag different resources that are created by that command. That's going to create disk, that's going to create network and such. So let's find again what are the tags specification. So if you search for this one, you're going to find an example here. So when you have to set the instance and the tags for the instance, and then you can set the volume, and you could potentially set other things. I'm just going to add a name to the instance itself. So first I'm going to create the public one, and the tag for that one I'm going to have a name, and the value for that name is going to be CLI public test. And I think that's all we need. Let's see if I made a mistake. And it seems like the machine is being created. Let's double check what we did. There we go. I'm going to delete the test we made before. And our machine is being provisioned. We can see that security group is here, public IP is here, and that's basically what we need. The key pair is here. So let's go ahead and create our private one as well. Let's call it private, and let's put a no public IP address. Now we are creating both of them. And let's copy our commands. Okay, so now that our instances are running, we can do the other part of the exercise, which is connect to them via SSH, which we already done before via the console. So I'm just going to skim through that a little bit fast in this one. So what we need here is to connect to this public machine using that public IP. So let's use it. Let's connect. We need to provide the identity for that one. I'm going to actually add that to my agent. I'm going to add that to my agent. So I'm going to add that to my agent. But actually I'm going to add that to my agent. And we have to remember that we need to also fix the permissions for that certificate. Okay, so there we go, exchange permissions. I added that to my keychain, so I should be able to simply do that now. I confirm I know that machine, and that's the public. There you go, that's the public EC2, and now I have to connect the private one. So if you remember how we did before, I'm going to use the jump host technique, which is I'm going to use this one as a jump to access that one. And there you go. That's the private one. I just forgot one thing. I have to document that. Now we add the answer. Now let's commit that with okay, I was just double checking if everything was all right, and the correct way to submit is not an answer.md, is a readme.md. So let's rename that. There you go. You're renaming it. Now I'm going to commit that. I'm going to amend because that was a mistake. Now edit because I don't want to change the commit message. And there you go. We don't have anything else there. Now, time to push. Yes, I am that lazy. And create our pull request. I think understand that it wants to review our commit. So that's I think that's one of the most important parts in a pull request, is that you come here, you check what was changed and make sure that you didn't put stuff by accident, you didn't change other code. Sometimes you apply a format and you start changing code from everybody else in different places. Yeah, I believe that a commit, like a pull request, should address just one concern. If you want to fix three or four different things, create 3 or 4 different pull requests. And the reason is sometimes you're going to approve some of this stuff. Sometimes 1 or 2 of them have something that someone don't agree or want to discuss more, and you don't want to block all the other changes that you made because of one thing. So if things are not related, make different pull requests. That's my opinion. But anyway, that's all I needed. It's here, and I think that's everything correct. And I believe that's what we need to do. That's the first one that I submit. So I might need to assign someone. I'll just submit it and see if their actions that they have is going to generate that for me. Although notice they mentioned before, I am doing a cross merge request, a cross pull request from my fork into theirs, and they already mentioned that it's not going to work some of the actions that they have. I'm going to leave this as is. Maybe next time I'm going to push straight away from a branch inside the repository. Let's see how things goes. But apparently it added properly, admins and instructors, and I believe it's all done.